so you
Okay.
can watch it again later. Okay.
Yeah.
All right. So
Okay.
you can watch it again later. Okay. So for some reason this takes a second here to load these days.
Yeah, that's okay.
You have a test or quiz coming up on this?
I have a quiz next Thursday, so I got a decent while.
Okay. Have we started like geometric and arithmetic yet? I'm going to try this again.
Yeah, we have.
Okay. So you're good with that? You know how those work?
I'm pretty sure, yeah.
I'm not sure why this is taking so long. It usually doesn't take quite this long. How many pages do you have filled up on this thing?
7.
Oh, that shouldn't be the problem. There we go. All right. So I'm just going to run straight through them. Okay.
Okay.
Stop me when you have a question. It says write the first 6 terms of the sequence. So the first term means n is 1. Do you see how I write it? That's your
Yeah.
n.
A sub
So
1 equals, yeah.
So just plug in 1 for any of the n's that you see.
Okay.
It's kind of like saying f of x equals 6 minus n squared. And then you then to find f of 1, remember function notation?
Mm-hmm.
It's kind of just like that. It's another way to use, it's a different type of notation.
Okay.
Okay. So this would equal 6 minus 1, which is this 5.
Okay, so you just square the 1 first, and then you just do 6 minus 1. Okay.
So that's the first term.
Yeah.
So your second term is going to be 6 minus 2 squared, which is just going to be 6 minus 4, which is 2. There's your second term. Your third term is going to be 6 minus 3 squared. Got it? Which is 6 minus 9, which is negative 3.
Yeah.
Your fourth term is 6 minus 4 squared, which is 6, whoops, not to the fourth. 6 minus 4 squared, which is 6 minus 16, which is negative 10. And your fifth term is 6 minus 5 squared, which is 6 minus 25, which is negative 19. And then the sixth term is 6 minus 6 squared, which is 6 minus 36, which is negative 30. So your first 6 terms, so the way you would write them is you would write 5, you'd write them as a sequence. 5, 2, negative 3, negative 10, negative 19, negative 30.
Okay, so that's how I write my answer. I don't just show like all my work, like how you have it all laid out there on the right. I just like write all
you can show your work, but this is your sequence.
Okay, yeah. That makes sense.
So sequences are lists separated by commas.
Okay.
And a series, if you've done those yet, is a sum of a sequence. So you're adding the values together.
Yeah.
So that's the difference between that and that. So same question, first 4 terms or 6 terms?
Yes.
So your first term is going to be, again, you're just plugging 1 in. It's 4 to the 1 minus 2, which is 4 to the negative 1. And do you remember what a negative exponent means?
Does it mean it's 1/4?
Perfect. Yeah. A sub 2 is 4 to the 2 minus 2, which is just 4 to the 0. You remember what anything to the 0 is?
It's either 1 or -1. Forgot.
It's 1.
Which one? Okay.
Yeah, it's 1. Because it's like it's saying there's none of those there. There's no 4s here. You can't write
Yeah.
0. You have to write 1, because if you wrote 0, then everything would become 0.
Okay.
Whoops. You'd cancel everything out. So what would the next term be?
It would be a sub 3 equals 4 to the 3rd minus 2 equals 4 to the 1st equals 4.
Good. You know what the next one's going to be?
Yeah, it'd be 4 to the 4th equals.
So
no.
do you see the pattern? This is one where you don't even really need to do anything, but just start listing them out.
Oh, is it 16?
It's going to be 16. Now multiply that by 4.
32.
So 16. Nope, 16 times 4. What's 16 times 4?
Oh, 64.
Yeah, 64. And then multiply that by 4. Do you see the pattern?
Yeah.
And there you go. There's your terms.
If I notice a pattern, do you think that they'll care if I just do that? Or do you think I should just work it all out?
If they do care, then they miss the whole point of sequences.
Okay.
Because the whole point of sequences is to notice patterns.
Yeah.
I would just say be careful that you don't make a mistake. Now do you notice what kind of pattern this is, or what kind of sequence this is?
No.
This is a geometric sequence.
I forgot what that means.
Have you learned that yet or no?
It sounds familiar.
So that means that there's a common ratio
Yeah. Of 4.
between terms. So the common ratio was 4, right?
Yeah.
You multiplied this by 4, you multiplied this by 4, you multiplied this by 4, this and this. That's why it would be surprising if they weren't okay with you just listing it out once you recognize the pattern. Now, this last one we did is not geometric, and it's not arithmetic. It's neither. And the way you can tell is the difference between these, 5 minus 2 is 3. The difference between these, 2 minus -3 is 5. These do not equal each other.
Yeah.
So these are your differences, and they don't equal each other. So that means it's not arithmetic.
Okay. So arithmetic means that there's
a common difference between terms.
Okay, yeah.
And then to find out if there's a common ratio, you're basically saying, does 5 times r equal 2? In other words, your ratio here, let me do the ratio between these, is going to be 2 divided by 5. And the common ratio here is -3 divided by 2. And are those equal to each other?
No.
Those are not equal, and that means that it is not geometric. So this sequence is neither geometric nor arithmetic. They don't have to be geometric or arithmetic. There's all kinds of sequences in the world, but geometric and arithmetic sequences are some of the most common ones, and there's usually the easiest ones to deal with. Okay, so we're going to get to that, I'm sure, at some point. So for this one, again, listing the first n terms. So what we're going to do is, or the first 6 terms rather. So the first term is going to be 1 over 2 times 1 minus 1, which is 1 over 1, which is just 1. Got it?
Yes.
The second term is going to be 2. See how I'm plugging in everywhere I see an n? I'm plugging in that number, which is 2 over 3. The next term is 3 over 2 times 3 minus 1, which is 3 over 5. Do you see a pattern yet?
Mm, no.
I see one, and what the pattern is the top, the numerator is just a arithmetic sequence in the numerator, and
Oh, it's just adding one.
the denominator is adding 2 each time.
Oh, okay.
So if you're confident that that's the pattern, you maybe aren't confident of that yet. I'm pretty confident. You'll see, oh yeah, that's exactly what's happening, because this is just going to be 7. So what's your next one going to be?
5/9.
Good. And what's your next one going to be?
6/11.
Perfect. There you go. So
Okay.
again, sequences are about noticing patterns. So go ahead and list it out. 1 2/3, 3/5, 4/7, 5/9, 6/11. There's your sequence. Okay.
Yeah.
Now they want you to determine what the sequence is from the pattern. So we're going to look at what we just looked at, because that kind of gives it away. You see how the sequence in the top was just n?
Mhm.
And look at how they did the sequence on the bottom. If you want to do just the odd numbers, look at what they're doing. They're starting with double of n, because that'll give you an even number.
Yeah.
And then they're subtracting 1, because that'll drop it back down to an odd number. Whoops.
Okay.
1
Yeah.
3 5 7. So that's a little trick for writing sequences. So let's see if we can figure that out. What's the top going to be? What's the top sequence going to be?
Is it 2n?
Very good. It's just 2n. That's right. It's an even number. 2n means it's always going to be even. And what's the bottom going to be?
Is that
Now we
Oh,
can't
is it?
just say n, because it starts at 3, right?
Yeah.
So we're going to say, remember, n starts at 1, right?
Yeah.
So what do I have to write down here if I wanted just to go up by 1 every time?
+1.
Well, I've got to start with 1, right? Start with my n. And then what am I going to add to that? If n is 1, what do I want this to equal?
I want it to equal 3. So
I want it to
add
equal 3,
2.
so I have to add 2 to it. And let's check if that works now. When I make it 1, for my first term, what am I going to have? 1 times 2 is 2 over 1 plus 2, which is
3.
3. How about when n is 2? What's 2 squared? 4. And what's 2 plus 2?
4.
4. 4 over 4. Look at that. By the way, they could have written that as just 1. They were being nice, and they wrote 4 over 4.
Oh, okay.
You see that?
Yeah.
If they hadn't written that, you should have like thought about it. Well, wait a minute. What if I rewrite 1? They might have just written 1 here, and then you could say, well, wait, I could rewrite 1 as 4 over 4.
Okay.
Right? Because it would be easier to see the pattern. But they were being nice to you, and they were kind of leaving it unsimplified so you could see the pattern. And then if I make it 3, if I make n 3, I'm going to get 6 on the top, and I'm going to get 5 on the bottom. So notice what's happening. This is doubling, or this is all even numbers, I should say. And then the bottom here, this is just starting at 2, but then it's going up by 1 every time. You're adding 1 every time. It's starting at 2 and you're adding 1. So that's just a little insight into how you make an arithmetic sequence, which we will learn soon. Okay, you good on that last one?
Yeah.
All right. So recursive means that you're creating a sequence instead of what we were doing back here. This was explicit. This is an explicit formula, because if I ask you like, hey, what's the 12th term of this sequence? How would you find the 12th term of this sequence?
I'd plug in 12 to n.
That's right. You plug in 12. And that would be easy to do, right? 24 over 14.
Yeah.
No problem, right? Well, a recursive sequence is where you're defining a term based upon the previous term. So you can't, this is called explicit. This is called an explicit formula. So let me write it out. A sub n equals 2n over n plus 2. That's how you should write it out. This is explicit formula. It's a formula based on n. A recursive formula means that you're defining it based upon previous terms. Defined based on previous terms.
That's what the n-1 means, right? The answer before.
Yep. So what this is saying is, see, notice they have to give you a starting point. So this is where you start. It says the first term is 2. And then it says, look at what this says. The nth term is equal to whatever n is plus the previous term. So this is defining the next term, defining the following terms.
So I know that the first one is 2. So if I went to the second one, would I just plug in 2 for n? So it'd just be 2 plus 2, right?
There you go. So a sub 2 would equal n plus a sub n minus 1, which means plus a sub minus 1, which means 2 plus a sub 1, which is the previous term, right?
Mm-hmm.
Here's your like you said, here's your previous term. Got it?
Yeah.
That's what I'm saying there. So this is just 2 plus 2. 2 plus 2 is 4. Now what do I do to find the next term?
You do 3 plus 2. Or 3 plus 4.
You do 3 plus 4, right? So I'm going to try to color code these things. So a sub 3 is going to equal 3 plus 4, because that's your previous term. And what's 3 plus 4?
7.
Good. And now what's your next term going to be?
It would be 7.
A sub 5 is going to equal
5
a
plus
sub
7.
4. Sorry, I said a sub 5. It should be a sub 4. A sub 4 equals
4 plus 7.
4 plus the previous term, which was
7.
And so your answer is
11.
11. Got it?
Yeah.
What's your next term going to be? A
It'd
sub
be
5.
Equals 5 plus 11.
Perfect.
So 16.
Which is 16. And what's your sixth term going to be?
A sub 6 equals 6 plus 16.
You got it. Which is?
22.
Good. Now, is this arithmetic?
No,
Whoops. How do you know it's not arithmetic?
because from 2 to 4, you're adding by 2, and then 4 to 7, you're adding by 3.
Perfect. And is it geometric?
No.
No, because 4 divided by 2 is 2, and 7 divided by 4 is not 2.
Yeah.
So that's why it's not geometric. Good job. That's what it means to be recursive. Okay.
Okay. Yeah.
It's kind of like you're building it as you go. So let's do this one. Now notice this one is defining. How is this one defining it? This is defining your term based upon the previous one. It's kind of writing it differently. This is the previous term, and this is the second, like 2 before. This is the 1 before term, and this is this 2 terms earlier. 2 terms earlier, I would say. 2 terms previous, maybe. That makes sense?
How does B sub n mean two terms previous?
Well, because they're telling you that your B sub n plus 2 term,
Oh,
third term,
yeah.
if n is 1, this would be your third term equals your first term plus your second times your second term.
Oh, okay, okay. Yeah, I got
Does
it.
that make sense?
Yeah.
So our first two terms are 2 and then 3. And our next term, so I'm going to do the little work down here, our B sub 3 is equal to B sub 1 times B sub 2, which is equal to 2 times 3, which equals what?
6.
6. And what's your next term equal to?
Um,
That's B sub 4. What would B sub 4 be equal to?
would it be B sub 2 times B sub 3?
Yep. See how that works? It's the two previous terms, which equals what?
Yeah. 3 times 6.
It's 3 times 6.
18.
And what does that equal? That's 18.
Yeah.
Yep. And what's your next term?
B sub 5 equals B to the third times B to the fourth.
Good. And I can just do that now, right? I don't have to color code them. 6 times 18, just to make sure we're doing this right. 108. So there's 108. What's your eighth or your sixth term?
108 times 18.
1944. So that is a recursive formula that's based upon two previous terms.
Okay.
A recursive formula can be based upon whatever you want it to be based upon previous. It could be 3, 4, 5, 6 terms if you wanted it to. But if you're going to do that, you have to make sure that you give the previous terms. Otherwise, it can't be done.
Yeah.
Right? So for this one, the recursive term was based upon one previous term only. And so they had to start you off with one term. For this one, it was based upon two previous terms. So it had to start you with two of them. Otherwise, you wouldn't be able to find it.
Okay. Yeah, that makes sense.
Okay. You got any more questions there?
Yeah. Wait, so for the one we just did, that wouldn't be arithmetic, right? But it would be was it geometric? Was that the word?
Is it geometric? 3 divided by 2, is that the same as 6 divided by 3?
Oh no, it's 3 over 1.
Is 3 over 2 the same as 6 over 3?
No. Okay.
So it is not. It's
right.
neither. This one's neither.
Are they often like one of them, or are they like
yeah, usually you'll do a whole homework set where you're dealing just with arithmetic or just with geometric. If you haven't done them yet, you'll be doing that soon.
Okay.
Have you not done it yet? If you're done, I can kind of explain it to you real quick.
Yeah, that's okay.
So an arithmetic sequence has a common term or a common difference. So if your nth term is going to equal it's going to equal your first term. You always have to start with the term plus the common difference times n minus 1. That's your formula for an arithmetic.
Okay.
So that has a common difference.
Yeah.
So for instance, an arithmetic could be like 7. Let's say the common difference is 3. It'd be 7, 10, 13, 16. Say I'm adding 3 each time. 19, 22. That would be an arithmetic sequence. And if you wanted to write the formula out, here's your a sub 1, and your common difference is 3. They got that?
Yeah.
So your formula would be a sub n equals 7. That's your first term, plus what's d?
3.
3 times n minus 1. Now you could simplify that if you wanted to, and sometimes they do have you simplify it, but that is the formula. If you wanted to simplify it, it would become 7 plus 3n minus 3, which just equals the 7 and the -3 add together. It's just 3n plus 4. So there's your simplest way to write that formula. But you kind of want to start it like this, because that formula is the formula that helps you understand. D is your common difference, and A1 is your first term. Okay.
Yeah, and then n is just whatever term we plug in.
Yeah, this is kind of like your x and your y.
Yeah.
Remember how you always have to have 2 variables when you're writing equations like this? This is like your x, and this is like your y. This is your independent variable. This is your dependent variable.
Okay.
Okay. And then geometric sequence is not much different. A geometric sequence, I'll try to fit it on this page. Instead of a common difference, it's a common ratio. So a sub n equals, you're going to have your first term, but then you're going to multiply it by your common ratio to the n minus 1 times. Do you see how I have an n minus 1 here multiplied by d?
Yeah.
And here I have an n minus 1, or I have a power, or the base of r, my ratio, raised to the power of n minus 1.
Yeah.
That's how you get the next term. The whole point of this is, what if n was 2? Look at the way that this works. If I'm talking about my second term, so my second term is 10, right? Follow me?
Yeah.
How many times do I add 3 to 7 to get to 10?
Once.
How many times did I add it? I added it 1 time. That's why I did 2 minus 1, because it gives you 1 d that you add to the a sub 1. But if I wanted my third term, how many times did I add 3 to get to my third term?
Twice.
I did it twice. So I had to do, for my third term, I had to, n minus 1 means 2. I added d 2 times to the first term. You see how that makes sense?
Yeah.
Okay, so for this one, it's the same concept, but now look at this. Let's say my geometric sequences, let's say I'm starting with 4, and let's say I'm multiplying it by 1/2 every time. So it's going to be 4, then 2, then 1/2, then 1/4, then 1/8, then 1/16. Do you see my sequence?
Yeah.
My first term is 4, and my common ratio is 2 divided by 4. Oh, I made a mistake here. Hold on. Did I say it was 1/2? So 1/2 of 2 is 1, and then it's 1/2, and then it's 1/4, and then it's 1/8. Okay.
Yeah.
So what is my common ratio? It was 1/2. So my formula would be a sub n equals 4, my first term, right, times r. What's r?
1/2.
1/2 raised to the n minus 1.
Okay.
And that would be my formula.
All right.
And again, look at what happens with this. How many times to go from 4 to 2, how many times did I multiply by the common ratio?
Once.
Once, and that's why I look up here. If I plug in 2 for a sub 2, look at what you're doing here. You're plugging 2 into this little formula up here. 2 minus 1 is 1. There's your one time. I'm only multiplying by r one time to get to a sub 2. To get to a sub 3, I had to multiply it 2 times.
Yeah.
So when you plug in a 3 here, that'll give you a 2, and that gives you the 2 times that you're multiplying by the 1/2. Because 1/2 to the second power means 1/2 times 1/2. You're multiplying it twice. Make sense?
Yeah.
All right. So you're probably going to learn that this next week. So hopefully that makes sense to you, and check it out on